Alright, so today we're going to be talking about magnets. So when we look at magnets, at either end of a magnet, we call those poles. There's a north or a south pole, and like are going to repel, so positive and positive or negative, negative, and then unlike poles are going to attract, so a negative or a positive. And the space around the magnet is the magnetic force, and that is where we experience the magnetic field. So inside the Earth, there is a nickel iron core, and that causes the Earth to actually act like a big magnet. And that is why a compass actually works, is because a compass is essentially a very small magnet that is elevated and can move freely around, and it points north because it is attracted to the magnetic south pole. So it points north, and we call that the north geographic pole, but that's actually the south magnetic pole of the Earth. So which of these are magnetic? So think about for a second which would be magnetic, which would be attracted to a magnet. A paper clip, aluminum foil, a nail, paper, a quarter, a penny, a razor blade, a sewing needle, wood, and nickel. So the ones that are magnetic are going to be turning green. So a paper clip, a nail, a razor blade, a sewing needle, and nickel, as in the element. So all of those would be magnetic, and a magnet would pick them up. So when an object is magnetic, it's most likely made out of a ferromagnetic element. These are strongly attracted to elements, and they're the most common are going to be iron, cobalt, and nickel. So those are the three ferromagnetic elements that are found. And the word ferromagnetic basically comes from the root word for element, iron. Inside a magnet, we have magnetic domains, and these are groups of atoms that are going to be going in the same direction, and we call these domains. So when an unmagnetized object is placed in a magnetic field, those objects can then become magnetized because their domains line up. So if you look at the image on the left-hand side, the domains are all loose, they're not in order, they have no direction, and that object would not be considered magnetic because the domains are not lined up. But when an object is magnetic, all the domains line up, they're in order, all the north point north, all the south point south, and so it causes that magnetic field to occur, and so it is a magnetic object at that point. So when making a magnet or using something to become magnetic, you usually want to find a hard ferromagnetic material, and that is because the domains are not going to be easily moved or shaken. And if you put a strong magnet next to a weak magnet, it can actually attract to both sides because it's going to cause the domains to shift in the direction that it wants. And then in order to lose magnetism, which you do not want to do, so if you have a magnet, you're going to want to try to avoid dropping it or heating it up. So if you continue to drop a magnet, that's going to shake up the domains and cause the magnetic force to become weaker. And also if you heat up the magnet, it's going to cause those domains to be able to move around and shake up a bit. And that's also going to cause the magnetic field to weaken. And that is it.